basically, you choose what you want. You choose your profiling mode. They have 4 different profiling modes. The most detailed one is line level timings, method level timings of everything. So you can tell it that you only want to profile stuff that it can find source code for, or you can also tell it you want it to profile everything. Even if it can't find the source code you want to know about it, it's what I typically use. Yes, it does result in a lot more detail, but ANS Profiler does a really good job of allowing you to get to relevant information. I'd rather do one profile and have too much data from methods and with and without source than to profile it, just have to go back and profile it again. You can choose whether or not you want to record that I/O performance from a SQL Server perspective and file system perspective. Typically, you want to turn that on, depending on what you're looking at. All of your startup options, etc., these will change depending on what type of project. One thing to note, it looks like we fill this out, we click OK. What we really want to do is there's a charting options tab here as well. What that does is it allows you to choose which performance counters and which other metrics, aside from your line level code timings and things you want to keep track of. You have access to all of the performance counters that exist on your machine, and it will keep track of them and chart them for you. So, you may want to keep track of, it automatically tracks processor time, but you may want to keep track of the .NET memory use in Generation 0, Generation 1, Generation 2. If you think you have a resource leak, you can track the size of Gen 0, Gen 1, and Gen 2 to be able to see that progression or see how things are going. You could profile an ASP.NET app and record things such as requests per second, things like that, so you can do other correlations as you go back and inspect your results. So, depending on exactly what you're looking for, there are options here. You just don't want to forget about it. Typically, I always do at minimum processor time and all of the memory items, just because you usually won't go wrong with having those, as well as percentage of time in garbage collection. If you have an app that's truly thrashing on memory use, you want to take a look at the time in garbage collection. Is it constantly having to collect and move memory around, which is going to block the app and keep it from running. Once you've done that, you run your application, do everything like you would normally do. Exit out of your application, the profiling stops. You can also manually stop it if you want to. But in the end, you get a display that looks somewhat similar to this. This is actually a screenshot from the last build of ANS Profiler. They changed a couple things slightly with the most recent release. But what you have with an ANS Profiler result set is typically you have 3 sections of information. You have your charts and the references around what was going on in the system at that point in time. In the middle, you have the call tree that gives you all of the important information about the application. And then you have a source code window at the very bottom that lets you do that final level of drill down. So, the summary view up at the top. On the left-hand side, you can choose which of the performance counters you want to look at, and then you have your timeline over here on the right side. With this, you can see that during this run of the application, the processor time spiked, dropped, and then the application exited. Looking at some of these other ones, Bytes from all heaps, and you can see how the memory use is constantly thrashing and turning as the application is running. Okay. We go in and look at the middle section. We see the call tree. We see all of the code that was executed. For each method, you get the method information, you get the time in milliseconds. You can actually change to look at it in milliseconds, wall clock time, a couple other things as well. But in the end, you get the time with children, which basically just means everything below it rolled up. And then you get a hit count, so you can validate how many times were things actually executed. So this looks at things at that summary level. If you don't do the most detail, this is the only level of detail that you get with your profile results. Now, in the end, in this scenario, I can still prove my point with only method level timings. We can see that string concatenation took 48.6 seconds to do 100,000 concatenations. we can see that the string builder method took 56 milliseconds. Major performance difference between them. ANS Profiler is also smart enough where it was able to identify this is a problem and gives it this little hot indicator on the side. So as you're looking at a result set at the beginning, you get some visual cues that, hey, this could be a problem. Now this is where validating that your test scenario was correct becomes important. If you have a long-running process, its indication of what is important is all based on total time with children relative to the running time of your application. So if you have a process that is inherently long-running, it's going to tell you that it's a problem, even though it may not be. So you always want to make sure that you are taking that into consideration when you're looking at things. Does it truly need to take as long as it's taking? It's one of the reasons why I always look at things in milliseconds. There's other time scenarios, but it becomes very hard to look at. Percentage of application run, you don't have as much control over. Milliseconds are milliseconds. They don't change no matter how long the application is running. You just have to take into consideration the hit count, too. Because you could have something that takes 12 minutes, but it was executed 100,000 times. Okay, that's fine. Something that took 12 minutes was executed once is a problem. The last level of detail that you can get, as long as you have source code available, is you can get results down at the line level. At that bottom section, as you click through each of those methods, the relevant source information will update. And with each of these, you get a hit count, you get an average time, a total time, and then you see your source code. Within here, everything is clickable from a drill down perspective. So you can click on method calls and jump to those other methods to look at the overall time of those. You can see in the end, this string concatenation on average only took not even half a millisecond. But the thing is, half a millisecond times 100,000 is a lot. This process was not able to be tracked out to 3 decimal places. The precision, the lowest number that you can get on any profile from ANS is 1,000th of a millisecond, is the best precision that you can get out of it. So with this one, you don't get much of anything. But in here, everything that we see makes sense, but there's one extra piece of interesting results here. Getting the length of this overall string for some particular reason actually took a lot longer than it took to get the length of the string builder string, even when we had to convert it to a string and then grab the length. I still don't actually know why this is the case, but I can recreate it all the time. But in the end, you can see from here, line by line, how many times was my loop executed, how many times was this condition evaluated. You can take a look at all of that at the most granular level possible. This is just another example of the timeline. Everything up to this line right here was the string concatenation process. This little blip was the string builder implementation when running that code. The other thing you can do is this timeline, you can drag and highlight different sections. So if you highlight, from 40 seconds to 50 seconds, everything downstream, so the method level stuff and the line level items all update accordingly. So I see that this is thrashing and this isn't, well, what was happening here? I can highlight this section and look at just that section. Everything else becomes discounted, all of the values update, and you're able to look at things at that level. Now, since a lot of you folks are ASP.NET developers, there's a couple things you want to be aware of when profiling ASP.NET apps. If you're profiling things from an IIS perspective, you won't see as much oddity in the environment when you use something like ANS Profiler. But if you use Cassini, if you tell ANS Profiler to start up the web development server and test your application, keep in mind that the web development server is a .NET process. So, that 30 seconds or so that it takes Cassini to start up and show that first page of your application, ANS Profiler is going to be profiling it, and it's going to show everything in there. It's going to show the spikes in the CPU. It's going to show the method calls, etc. My recommendation for people that are profiling ASP.NET apps with Cassini is start your debug session, wait 15 or 20 seconds after the